radius away. So we want to hold the antenna as steady as we possibly can for that whole time.
And how do you do that?
We have little engines or thrusters that we use to hold us steady.
Wonderful. So that's, and basically we will lose the battle with Saturn's atmosphere, though.
We will. And if we go to the graphic here, we see the thrusters firing as we try and hold that antenna for as long as we can. And that will last for only about a minute until the thrusters are finally overwhelmed and we can no longer point the antenna.
Wow, that's amazing. But those precious seconds of science data are worth every thruster pulse we put on the
every second. Yeah, we're learning all about Saturn's atmosphere with all the instruments we can as we go in. So yeah, we want to point as long as we can.
So you started your career on this mission. How are you feeling tonight, knowing we have to say goodbye to our beautiful spacecraft?
It's definitely bittersweet. Yeah, I started my career. I was in high school when Cassini arrived at Saturn. So it's really exciting, and I'm really proud to have worked on such, incredible mission and be part of such a wonderful family. But it's going to be sad, I'm used to checking how the spacecraft is feeling every morning and things like that. So it'll be a little sad to not have that anymore.
I definitely agree there, and we're so grateful for your contributions and all the young engineers on the project, as well as the veterans that have been around since launch. Thank you, Joni.
What would people do without the veterans?
we got a few tricks up our sleeves still. So if we can head back to the radio science display and check and see, still looking good. So we have a strong X and S band signal. So as Earl mentioned, our fate is sealed. We've met our planetary protection requirement. We know we're going to impact Saturn and take care of that. The next thing that's important is to hold that signal as long as possible and get every last precious bit of science data. So far so good, Gay. Back to you.
Thanks, Todd. Thanks, Joni. It is about 33 minutes past the hour, and the estimated time of loss of signal is 4:55 a.m. Pacific. The Cassini-Huygens mission has been an epic adventure around the Saturn system. It has sent home mountains of science data, stunning images. The spacecraft performed beautifully. The mission fulfilled its goals and then some. Members say they couldn't have asked for anything more.
This is Titan Launch Control. All the systems are go.
I've worked on the Cassini project for almost 30 years, and that's an entire Saturn orbit.
The beauty of Cassini is the design. It's the largest outer planetary spacecraft ever built. 12 different instruments, the Huygens probe built by the European Space Agency. It's just a monumental machine.
3, 2, 1, and liftoff of the Cassini spacecraft on a 30-mile trek to Saturn.
We turned the Cassini cameras down to look at the rings, revealing them in a way we had never seen them before. I remember coming back to JPL early in the morning just so I could be there. and watch those pictures one by one come down. And I felt like I could almost reach out and touch the rings that were right there.
We had been collaborating with the Europeans ever since launch to make sure that we had everything right for Huygens. The Huygens probe was dropped onto Titan. These are images from 1 billion miles away on the surface of Titan. They're boulders, they're pebbles. We're in a dry lake bed. And I still get goosebumps just talking about it.
Looking back at what we were planning to do in those first 4 years, we've gone so far beyond that.
We remapped our investigations to concentrate on the questions that Cassini raised.
2 of our instruments actually sampled the plume of Enceladus as we flew through, tasting the gas, measuring the particles in a way that we hadn't planned. Cassini has changed the paradigm of where we might look for life. That will be one of her legacies.
13 years of exploring Saturn. It really is just an awesome mission.
All right, well, joining me now is NASA Director of Planetary Science, Jim Green. Some of Cassini's greatest accomplishments came as big surprises, didn't they?
They did, absolutely. You know, one of the ones that's pretty spectacular, obviously, is Enceladus. Now, you may not really understand the importance of having a spacecraft with all kinds of instruments, including magnetometers and plasma wave instruments, but it was really discovered, the plumes, by a magnetometer. And so as the spacecraft was doing a flyby, what was happening is the plumes were being blasted out of the tiger stripes, they were being ionized, and they're loading down the field, dragging it by. And so the magnetometer saw the wave of the field in a place that they hadn't expected. And that gave a hint that something was going on and it needed to be looked at. And so then the next pass, they came up with the idea, well, let's look at it in backlight. And wow, there were the plumes. And that started then a series of new orbits and new trajectories to try to go through and taste the plumes and get even more details about what's happening at Enceladus.
And how does this discovery sort of change the way we look for life in the solar system?
Well, this is really a calling, if you will, of hey, you're going to have to come back because there's several things we know about life. One, it metabolizes. That means it takes in a liquid. It then uses that to extract energy, and then the liquid is used to extract the waste. But then it evolves, and then it also reproduces. Well, I can't measure any of those from our spacecraft other than going after the water. So once we see an area that has water, then we know that it has a possibility of being a habitable environment.
And transitioning to the other big story, also from Cassini, is another moon, Titan.
Oh, yeah, Titan. What a beautiful moon this is. You know, it's bigger than the planet Mercury. Its atmosphere is actually a significant one. It's twice the pressure that we have here on Earth. It's similar in the sense that it has a lot of nitrogen. In fact, it's dominated by nitrogen. But it also has liquid on its surface, which we know now is methane. And there's a hydrological cycle of evaporation, transport, rain, and then new lakes are forming in other locations on the moon.
And that's an incredible science legacy, but Titan also helped us with an engineering legacy as well.
Oh, absolutely. The concept of using Titan to do a gravity assist, swing bys, that then enable those spacecraft to get into different orbits is a fabulous concept, because while we're doing that, you know, and here's the koosh ball, as we say, all these spectacular flybys allow us to look at Titan in detail. So from multiple flybys, we can get a global view of that moon, and we're using that same concept at Jupiter with another moon called Europa.
All right, well, before we go, I wanted to bring up the e-book because
Yeah.
one of the most fantastic
Yeah.
things about this mission has been the imagery. Could you
Yes.
tell us a little bit about that?
Well, we really needed to make sure that we had wonderfully described and beautifully set images that were accessible to everyone. And after 450,000 plus images, it's so hard to pick. But we were able to go back in, get 100 beautiful images or more, and videos and all kinds of.
And there's a link where if you want to get it, you can download it off the internet.
NASA.gov/ebooks.
All right. Well, Jim, thanks for joining us. Thanks for taking time for us.
My
and
pleasure.
I know you want to get back into that control room.
Absolutely.
Thank you.
Thank you.
how little fuel we have left. It's about 1% plus.
Going to start accumulating. Copy.
That means we're just starting to sense the atmosphere, right?
Yep, we can start seeing.
That means we're just starting to sense the atmosphere, right?
Yep, we can start seeing
This is ACS1.
the spacecraft starting to lose the battle with the atmosphere.
Systems ACS1. We're still waiting for transition to high rate mode, but it looks like we're going to start accumulating thruster on time. And with this, we're going to start seeing thruster on time at a higher rate now. Very quickly. Our attitude control error is been clamped down to 0.5.2 millirad, and we are in the atmosphere.
Copy, thank you.
Roughly 1 minute to loss of signal.
Systems, this is Nav. Go ahead, Nav.
Systems ACS1, we just had the transition to high rate mode, and with this, we're going to start seeing thruster on time accumulating very quickly, and the deadband has been clamped down to 0.5.52 millirad, and we are in the atmosphere.
Copy, thank you.
Yeah.
Systems, this is Nav. Go ahead, Nav. We can confirm.
Radio signal still holding.
Yeah.
30 seconds.
Copy, thank you.
Systems lead, mission planning.
Go ahead, mission planning.
Spacecraft has just crossed 10 degrees north latitude, altitude 1,000 miles.
Copy, thank you.
Are we ready for that then?
Systems ACS1.
Go ahead.
With the additional thruster on time, we're going to also see the deadband start riding. Systems lead, mission planning.
Go ahead, mission planning.
Spacecraft has just crossed 10 degrees north latitude, altitude 1,000 miles.
Copy, thank you.
Systems ACS1.
Go ahead.
With the additional thruster on time, we're going to also see the deadband start riding.
Copy.
We'll let Jamie call it.
Flight Director, ready science.
Go ahead, Flight Director.
We have lots of signals at X-ray band and zero band.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal, loss of X-band at call loss of signal at 115546 for the S-band, so that would be the end of the spacecraft.
Copy that.
Project Manager on FSO Quard. Maybe a trickle of telemetry left, but just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project manager off the net.
So just a short time ago, Julie Webster, the Space Operations Team Manager, and Program Manager Earl Mays called it the end of mission for Cassini. It came at about 4:55 as predicted. Let's go now to Beckman Auditorium and check in with Morgan Cable. She is with Cassini interdisciplinary scientist Jonathan Lunine to find out how the scientists are doing and the team is doing down there. The mission is certainly not over for them because now there will be tons of data for them to be poring over. Morgan?
That's a very good point, Gay. There's going to be lots of data to analyze for years to come. Jonathan, how are you feeling right now?
I'm actually breathing again, and I feel sad, but we felt sad the whole week. We knew this was going to happen, and Cassini performed exactly as she was supposed to, and I'll bet there's some terrific data on the ground now about Saturn's atmosphere.
I'll bet you're right. What was your favorite memory of Cassini? Well, or share a story, just anything that comes to mind.
My two favorite moments were both having to do with Titan. One was seeing the seas of Titan for the first time from the radar on Cassini, and the other was seeing the surface of Titan from the Huygens probe, sitting with 30 other people in a trailer in the middle of Germany in the middle of winter. It was cold and dark, and there were the first pictures of gullies on the surface of an alien world.
That had to just blow your mind.
It did. I was screaming. So was everyone else.
Well, I think the mood's been a little bit more somber now, but there was applause right near the end. I think this is a celebration of Cassini's life and Cassini's legacy, and we should talk a little bit about the future. What do you see next for the Saturn system?
Well, what I would like to see next for the Saturn system is that we go back there. And there's so many things that Cassini has given us in terms of a legacy to explore. Enceladus and the possibility of life, Titan and its amazing atmosphere and lakes and seas and hydrologic cycle, Saturn and the rings and the mysteries of what lies beneath the clouds. There's an awful lot that Cassini has said to us we must go back and explore.
Yeah, there's a lot left to do in the Saturn system and elsewhere in the solar system as well. Yeah. Well, this has been an international mission and an intergenerational mission, right? It's been such a joy for someone like me to be able to be mentored by veterans like you. In terms of following on Cassini's legacy and mentoring the next generation, what do you see in terms of next missions coming up, being able to bring in the next generation of scientists and engineers?
First of all, I'm very, very confident and optimistic about the next generation because I can see that the experts are here already. So we will be well served in the future. Of course, NASA is going back to Europa with the Europa Clipper, which is very exciting, and the Europeans are doing JUICE to the other Galilean moons, and there are a number of concepts out there for going back to Enceladus and Titan and to Saturn. We don't know if any of those are going to happen in the next few years, but we'll see. There are lots of ideas. The important point is that Cassini has got to be a jumping off point to even more exciting exploratory missions. We can't let it stop at this point. We have to keep going on. We will in the Jupiter system. We need to go back to Saturn. We need to go to Uranus and Neptune. We need to do the whole outer solar system.
We need to. The outer planets, I think one of the amazing things that Cassini has shown us is that it's not a boring, cold place. It's dynamic. It's so incredibly varied. Just the differences in the moons of Saturn alone. It inspires us to want to go back and to learn more.
Yeah, you know, 40 years ago, Voyager 1 was launched. And it was Voyager 1 and 2 that broke open the outer solar system for us, told us that this was not a cold, dead, gray place. And then Galileo and Cassini followed on and showed us what really amazing things are going on in those systems, and that there might in fact be places for life to exist in Europa and Enceladus and Titan. And I have a poem I want to read to you as well at some point. Is this a good time?
I think it's a great time.
Okay. You know, a lot has been said about and the end of the mission, but I think that the best I can do to leave this celebration of Cassini's end is to read a bit of a poem by Swinburne, On the Verge, which was a nautical poem about death and dying, death sailing on the sea as a metaphor for death. And so I'm going to read the last few lines of it, and I've changed one of the words. It'll be obvious. Ah, but here Cassini's heart leaps, yearning toward the gloom with venturous glee. Though her pilot eye behold nor bay nor harbor, rock nor shoal, from the shore that hath no shore, beyond it set in all the sea.
You had to do that, didn't you?
I did. Sorry.
Thank you, Jonathan, for everything.
Well, Morgan, the future is in your hands and the hands of your generation, and this was a moment of transition. It was not the end. And so let's go forth and explore the solar system together.
All right. That's a beautiful sentiment. Well, with me now is NASA Associate Administrator for Science, Thomas Zurbuchen. Dr. Zurbuchen, what was your reaction being in that control room?
Well,